Intensive practice 7.2, questions number 1. For each of the following, determine whether the lines AB and CD are parallel or perpendicular to each other. So here we want to use the gradient for AB and CD to determine they are parallel or not. As the coordinate for each point is given, we're going to find the gradient using the formula y2 minus y1 over x2 minus x1. For questions A, the gradient AB is equal to 2 minus 4 divided by 6 minus 3. So this is equal to negative 2 over 3. So this is equal to negative 2 over 3. As for the gradient CD, this is equal to negative 1 minus 3 over 3 minus negative 3. So this is equal to negative 4 over 6. So simplify this is also equal to negative 2 over 3. So as the gradient AB and CD, they are the same, then the straight lines AB and CD are parallel to each other. For questions B, the gradient of AB is equal to negative 3 minus 4 divided by 4 minus negative 3. So this is equal to negative 7 divided by 7, which is equal to negative 1. As for the gradient CD, this is equal to 4 minus 1 divided by 1 minus negative 2. So this is equal to 3 over 3, which is equal to 1. So here the gradient of AB is not equal to CD. So AB is not parallel to CD. And when we multiply the gradient AB with the gradient of CD, this is equal to negative 1. Then AB is perpendicular to CD. Questions number 2. Given A 1, 2, B 6, 8, and C 12K are the vertices of a triangle such that angle ABC is equal to 90 degrees. Find the value of K. So probably the triangle ABC will look like this. So first we're going to find the gradient of AB. So the gradient AB will be 8 minus 2 divided by 6 minus 1. So this is equal to 6 over 5. As BC is perpendicular to AB, so when we multiply the gradient of these two straight lines, it will be equal to negative 1. So here 6 over 5 times the gradient BC, this is equal to negative 1. So the gradient BC is equal to negative 1 divided by 6 over 5. So this is the same as negative 1 times 5 over 6. So the gradient BC is equal to negative 5 over 6. So now when we use the coordinate of the point B and C, we can also find the gradient, which is going to be equal to 5 over 6. So when we take K minus 8 over 12 minus 6, the answer will equal to negative 5 over 6. So here it will be K minus 8 over 6 equal to negative 5 over 6. So move the 6 to the right hand side. So K minus 8 equal to negative 5 over 6 times 6. So cancel the 6. K is equal to negative 5 plus 8. Then K is equal to 3. Questions number 3. Given P 73, Q 22, and R negative 14, finds A the equations of straight lines that pass through point P and is parallel to QR. So based on the diagram here, we want to find the equations of the straight lines in the green color. So as the two straight lines, they are parallel to each other, then they're going to have the same gradient. So to find the gradient of QR, it will be 4 minus 2 over negative 1 minus 2. So this is equal to negative 2 over 3. So now we already know the gradients, and the coordinate of one point that passes through the straight lines. Then to find its equations, we're going to use y minus y1 equal to m bracket x minus x1. So y minus 3, this is equal to negative 2 over 3 times x minus 7. So y is equal to, expand this, negative 2 over 3x plus 14 over 3, and move the negative to the right hand side, it will be plus 3. So y is equal to negative 2 over 3x plus 23 over 3. That will be the equations in the gradient form. Questions B. Find the equations of straight lines that passes through point R and is perpendicular to QR. Then finds the coordinates of S such that both lines intersect. So here we want to find the equations of the straight lines that is in the blue color in the diagram. As the two straight lines is perpendicular, this means when we multiply both of the gradient, the answer is equal to negative 1. So when the gradient of the perpendicular lines times the gradient of QR, which is negative 2 over 3, the answer is equal to negative 1. So the gradient will equal to negative 1 divided by negative 2 over 3, which is the same as multiplied by negative 3 over 2. So here the gradient is equal to positive 3 over 2. So now we have the informations of the gradients and the coordinate of one point that passes through the straight lines. Then we can find its equations. So it will be y minus 4 equal to 3 over 2 x minus negative 1. So y is equal to 3 over 2 x plus 3 over 2. Then move the negative 4 to the right hand side. It will be plus 4. So y is equal to 3 over 2x plus 11 over 2. So that will be the equation of the straight lines in the gradient form. So now we want to find the coordinate S. So here will be the position of the point S. As we have the equations of both straight lines, then we're going to solve this using the simultaneous linear equations method. So first, I'm going to let this equation as number 1 and this equation as number 2. So here I'm going to sub equation 1 into equations number 2. So this will be 3 over 2x plus 11 over 2. This is equal to negative 2 over 3x plus 23 over 3. To solve for the x, we're going to collect the x on one side and the number on the other side. So 3 over 2x plus 2 over 3x, this is equal to 23 over 3 minus 11 over 2. So we're going to get 13 over 6x is equal to 13 over 6. So x is equal to 13 over 6 divided by 13 over 6, which is equal to 1. To find the y, I'm going to sub the x equal to 1 into the equations number 1. So y is equal to 3 over 2 bracket times 1 plus 11 over 2. So y is equal to 7. Then the coordinate S is 1, 7. Questions number 4. The coordinates of 3 points are P, negative 1, negative 6, Q, 3, negative 12, and R, E6. Finds the value of constant E if A, PQR are collinear. So based on the coordinate, this will be the straight lines PQR look like. As this is collinear, then this means the gradient for any points that is on the straight lines will be the same. So here as the coordinates of P and Q are given, so we're going to use these 2 points to find the gradient. So the gradient will equal to negative 6 minus negative 12 over negative 1 minus 3. So here negative 6 plus 12 is equal to 6, and negative 1 minus 3 is equal to negative 4. Simplify this, the answer is equal to negative 3 over 2. So now if we use the point R and the point P, for example, to find the gradient, the answer will still equal to negative 3 over 2. Therefore, when we take 6 minus negative 6 over e minus negative 1, the answer is equal to negative 3 over 2. So 6 plus 6 is equal to 12 over e plus 1. This is equal to negative 3 over 2. So here using the cross multiplications method, so 3 times e plus 1, this is equal to 12 times negative 2. So here after expanding, we're going to get 3e plus 3. This is equal to negative 24. So 3e is equal to negative 24 minus 3. So e is equal to negative 27 divided by 3. So the value of e is equal to negative 9. And for questions B, we want to find the value of constant e if PQ is perpendicular to PR. So based on the coordinates, this will be the diagram for the situation in B. So in questions A, we already find the gradient using the point PQ, which is equal to negative 3 over 2. As these two straight lines that are perpendicular, this means when the gradient PQ multiply the gradient of PR, the answer is equal to negative 1. So negative 3 over 2 times the gradient of PR is equal to negative 1. Then the gradient of PR is equal to negative 1 divided by negative 3 over 2, which is the same as negative 1 times negative 2 over 3, which is equal to positive 2 over 3. So now if we use the coordinate of the point R and point P to find the gradient, the answer is equal to 2 over 3. So when 6 minus negative 6 over e minus negative 1, this is equal to 2 over 3. So 12 over e plus 1, this is equal to 2 over 3. So using cross multiplications method, 2 times e plus 1, this is equal to 12 times 3. So 2e plus 2, this is equal to 36. So move the positive 2 to the right hand side. So 2e is equal to 36 minus 2, which is equal to 34. So e is equal to 34 divided by 2, which is equal to 17. Question number 5. Given 4 points P negative 6, 1, Q 1, negative 2, R 0, 5, and S negative 3, H. If PQ is perpendicular to RS, finds the value of constants H. So based on the coordinates, this will be the diagram look like. And just let's say the point S is located here. So first we're going to find the gradient of the straight line PQ. So it will be 1 minus negative 2 over negative 6 minus 1. So this is equal to 1 plus 2, which is 3, over negative 7, which is negative 3 over 7. So as these two straight lines, they are perpendicular, which means when the gradient PQ multiply with the gradient RS, the answer is equal to negative 1. So here when negative 3 over 7 times gradient RS, this is equal to negative 1. Then gradient RS is equal to negative 1 divided by negative 3 over 7, which is the same as negative 1 times negative 7 over 3, which is equal to positive 7 over 3. So now using the coordinate R and S, the answer of the gradient is equal to 7 over 3. So when H minus 5 over negative 3 minus 0, the answer is equal to 7 over 3. So h minus 7 over negative 3, this is equal to 7 over 3. So using cross multiplications method, so 3 times h minus 5, this is equal to negative 3 times 7. So 3h minus 15, this is equal to negative 21. So 3h is equal to negative 21 plus 15, which is equal to negative 6. Then h is equal to negative 6 divided by 3, which is equal to negative 2. Questions number 6. In the diagram on the right, OC is perpendicular from origin O to straight line AB, such that point A is 0, 5 and point B is 10, 0. Find A, the equation of straight line AB and OC. So here, the point A is actually the y-intercept, and the point B is the x-intercept. So to find the gradient AB, we're going to use the formula negative y-intercept over x-intercept. So the gradient AB is equal to negative 5 over 10. Simplify this is equal to negative 1 over 2. So here we already know the y-intercept is equal to 5, which is the C. So to find the equation, it will be y equal to negative 1 over 2x plus 5. So this equation is in gradient form. As OC is perpendicular to AB, this means when we multiply the gradient of OC with the gradient of AB, which is the negative 1 over 2, the answer is equal to negative 1. Then the gradient OC is equal to negative 1 divided by negative 1 over 2, which is the same as negative 1 times negative 2 over 1, which is equal to positive 2. So based on the diagram here, the straight line OC, the y-intercept is equal to 0. So using y equal to mx plus c, then the equation OC will be y equal to 2x. Questions B. Finds the coordinate of C and distance OC. So here the point C is the intersection point between the straight lines AB and OC. To solve this, we're going to use the simultaneous linear equations method. So here I'm going to let the equations of AB, this one as my equations number 1, and the equation OC as the equations number 2. So here I'm going to sub the equations number 2 into the equations number 1. So this will be 2x equal to negative 1 over 2x plus 5. Next, move the x at the left hand side. So 2x plus 1 over 2x equal to 5. So 5 over 2x is equal to 5. So 5x is equal to 5 times 2 is equal to 10. Then x is equal to 10 divided by 5, which is equal to 2. To find the y, I'm going to sub the x equal to 2 into equations number 2. So y is equal to 2 times 2, which is equal to 4. Therefore, the coordinate C is equal to 2, 4. To find the distance OC, we are going to use this formula. So as the coordinate of the origin is 0, 0, then to find the distance OC, it will be square root 4 minus 2 minus 0, which is equal to 2, then square it. And 4 minus 0, square it, it will be 4 square. So the answer for this will equal to 4.472 units. Questions number 7. The diagram on the right shows a parallelogram ABCD. Points A and D are 1, 2, and 3, 6 respectively. Equations of the straight line DC is 3y minus x equal to 15. DE is the perpendicular bisector of AB. Finds A, the equations for AB and DE. To form the equations, we just need the coordinates of any point on that straight lines with its gradient. For the straight lines AB, we already know the coordinate of the points A, so we just need to find the gradient of AB. As AB is parallel to CD, then they are having the same gradient. So here we're going to convert the equations DC into gradient form, which is y equal to mx plus c. So move the negative x to the right hand side. 3y is equal to x plus 15. Then move the number 3. So y is equal to 1 over 3x plus 15 divided by 3 is 5. So the gradient is 1 over 3. So the gradient AB is also equal to 1 over 3. To form equations AB, we're going to use y minus y1 equal to m bracket x minus x1. So here it will be y minus 2 equal to 1 over 3 bracket x minus 1. So expand this, y is equal to 1 over 3x minus 1 over 3. Then move the negative 2 to the right hand side. It will be plus 2. So y is equal to 1 over 3x plus 5 over 3. So this will be the equations AB in the gradient form. As for straight lines DE, we already know the coordinates of the point D. So we just need to find the gradient of DE. As DE is the perpendicular bisector of AB, this means when we multiply the gradient of DE with the gradient of AB, this will equal to negative 1. So here, 1 over 3 times gradient DE equal to negative 1. Then move the 1 over 3 to the right hand side. It will be negative 1 times 3, which is equal to negative 3. So using the same methods that we find equations AB, so the equations DE will be y minus 6 equal to negative 3, x minus 3. So expand this, y is equal to negative 3x plus 9, then move the negative 6 plus 6. So y is equal to negative 3x plus 15. So here I just going to leave the answer in the gradient form. Questions B. Finds the coordinates of E and B. As DE is the perpendicular bisector of AB, this means the point E is the midpoint for the straight lines AB. And the point E is also the intersection point between the straight lines AB and DE. So in questions A, we already find the equations for AB and DE. So we're going to solve the equations here using the simultaneous linear equations method to find the coordinate of point E. So here I'm going to let the equations AB as my equations number 1, then the equations DE as the equations number 2. Then I'm going to substitute the equations 1 into the equations number 2. So this will be 1 over 3x plus 5 over 3. This is equal to negative 3x plus 15. So here, if you don't want to deal with the fractions, then here we're going to multiply each terms here with number 3. So when 1 over 3x times 3, so the number 3 here will be cancelled, and when 5 over 3 times 3, the 3 will be cancelled as well. So what left is x plus 5, this is equal to negative 9x plus 45. Then I'm going to collect the x on the left hand side and the numbers on the right hand side. So x plus 9x is equal to 45 minus 5. 10x is equal to 40. Therefore, x is equal to 40 divided by 10, which is equal to 4. Next, to find the y, I'm going to substitute the x equal to 4 into the equations number 2. So y equal to negative 3 times 4 plus 15. So negative 12 plus 15. So y is equal to positive 3. Therefore, the coordinate E will be 4, 3. Now we're going to find the coordinate point B. So as E is the midpoint of AB, this means the ratio AE to EB is equal to 1, 1. So here, when 1 times x, which is x, plus 1 times 1, which is 1. Then we divide with the total ratio, which is 1 plus 1, equal to 2. The answer here is equal to 4, which is the coordinate x of the point E. So here x plus 1 is equal to 4 times 2, which is equal to 8. Then x is equal to 8 minus 1, which is equal to 7. And when 1 times y, which is y, plus 1 times 2, which is 2, divided by the total ratio, 2, this is equal to the y coordinates of the point E, which is the 3. So here y plus 2 is equal to 3 times 2, which is 6. So y is equal to 6 minus 2, which is equal to 4. Therefore, the coordinate of point B is 7, 4. Questions number 8. The diagram on the right shows a trapezium ABCD. The coordinates of A, B, C, and D are A, 3, 6, B, 11, 10, C, 9, 4, and D, 5, 2 respectively. A, determine the pairs of parallel and perpendicular lines. So, a trapezium is a quadrilateral with one pair of sides that are parallel. So, based on the diagram here, AB is parallel to CD. And for the straight lines AB and AD, they are perpendicular, as we have 90 degrees at the point A here. And for the straight lines AD and CD, they are also perpendicular to each other, as the intersection point at the point D, they are 90 degrees. Questions B. Find the equations of straight lines AB. So first, we're going to find the gradient AB using the coordinate point A and B. So the gradient AB will be 10 minus 6 over 11 minus 3. So this is equal to 4 over 8. Simplify this, the answer is 1 over 2. So to form the equations AB, besides the gradient, I also need the coordinates of any one point that is lines on the straight lines AB. So here I just going to choose the point A. So here y minus 6 equal to 1 over 2 bracket x minus 3. Next, y is equal to, expand this, you'll get 1 over 2x minus 3 over 2. Then move the negative 6 to the right hand side, it will be plus 6. Therefore, y is equal to 1 over 2x plus 9 over 2. That will be the equations AB in gradient form. Question C. A straight line passes through point C and is perpendicular to AB. Find the equations of the straight lines. Show that the straight line passes through the midpoint of AB. So the equations that we want to find will be the equation of the straight lines that is in the blue color here. At the straight lines is perpendicular to AB, this means when we multiply the gradient together, the answer is equal to negative 1. So let's say we label the intersection point between the straight lines to the AB here as the point E. So the gradient CE times 1 over 2, this is equal to negative 1. Then the gradient CE is equal to negative 1 times 2. This is equal to negative 2. As the straight line CE passed through the point C and we know its coordinate, so we're going to use this to form the equations. So y minus 4, this is equal to negative 2, x minus 9. So y is equal to, expand this, negative 2x plus 18, and move the negative 4, it will be plus 4. So y is equal to negative 2x plus 22. That will be the equation CE in gradient form. Next, we want to show that the straight line passes through the midpoint of AB. As we know the coordinates of point A and B, we can find its midpoint. So the ratio involved here is 1 to 1. So to find the midpoint, it will be 1 times 11, which is 11, plus 1 times 3, which is 3, then divide by the ratio 1 plus 1, which is 2. And for the y coordinate, it will be 1 times 10 plus 1 times 6, then divide by 2. So here we have 14 over 2 and 16 over 2. So this is equal to 7, 8. To show that the point E is the midpoint of AB, we are going to substitute the coordinates of the midpoint AB, 7, 8, into the equation CE. And if the coordinate of the midpoint AB satisfies the equation CE, which means the value on the left hand side is equal to the value of the right hand side after we substitute it the coordinate, then this means the point E is the midpoint of AB. So 8 is equal to negative 2 times 7 plus 22. So 8 is equal to negative 14 plus 22. So 8 equal to 8. So here the value on the left hand side is equal to the value on the right hand side. Therefore, we already shows that the straight lines passes through the midpoint of AB, which is the 7, 8. Question number 9. The diagram on the right shows a triangle ABC such that A 9, 9 and C 1, negative 3. Point B lies on the perpendicular bisector of AC, and the equations of the straight lines AB is y equal to 8x minus 63. A finds, number 1, the equations of perpendicular bisector of AC. So the blue straight lines on the diagram here is the perpendicular bisector of AC, and it divides the straight lines AC into two equal halves, which means the intersection point here will be the midpoint of AC. So the ratio here will be 1 to 1. So first let us find the coordinates of the midpoint AC. The x coordinate will be 9 plus 1 and divide by the total ratio, which is 2. And for the y coordinate, it will be 9 plus negative 3 divided by 2. This is equal to 10 over 2 and 6 over 2. Simplify this, the midpoint AC is 5, 3. So to find the equations of the perpendicular bisector, we still need to find its gradient. So first we want to find the gradient AC. So the gradient AC will be 9 minus negative 3 over 9 minus 1. So this is equal to 12 over 8. So simplify this, the answer is equal to 3 over 2. So when the gradient of the perpendicular bisector of AC, let's say we label this as the MP, when we multiply with the gradient of AC, the answer is equal to 1. So when MP times 3 over 2, the answer is negative 1. The gradient of the perpendicular line will be negative 1 divided by 3 over 2, which is the same as negative 1 times 2 over 3. So the answer is negative 2 over 3. So now we already have the coordinates of one point that pass through the perpendicular bisector of AC and its gradient. Then we can find its equations. So y minus 3, this is equal to negative 2 over 3 x minus 5. So y is equal to negative 2 over 3x plus 10 over 3. Then move the negative 3 to the right hand side, it will be plus 3. So y is equal to negative 2 over 3x plus 19 over 3. So that will be the equations in the gradient form. A2 finds the coordinates of B. So here the point B is the intersection point between the straight lines AB with the perpendicular bisector of AC. And we have the equations for both straight lines. To find the intersection point, which is the B, we're going to solve these two equations using the simultaneous linear equations method. So here I'm going to label the equations AB as equations number 1 and the equations of the perpendicular bisector AC as equations number 2. So next I'm going to substitute equations 1 into the equations number 2. Then it will be at x minus 63, this is equal to negative 2 over 3x plus 19 over 3. So let's say we don't want to deal with the fractions here. Then for every terms here, I'm going to multiply it with 3. So when negative 2 over 3 times 3 here, the 3 will be cancelled. This is the same as 19 over 3 times 3. So 3 times 8x, this is equal to 24x, and 63 times 3 is equal to 189. This is equal to negative 2x plus 19. Then collect the x on the left hand side and the numbers on the right hand side. So 24x plus 2x, this is equal to 19 plus 189. So 26x is equal to 208. So x is equal to 208 divided by 26. X is equal to 8. To find the coordinate y, I'm going to substitute the x equal to 8 into the equations number 2. So y is equal to 8 bracket times 8 here minus 63. So this is the same as 64 minus 63. So y is equal to 1. Therefore, the coordinate b will be at 1. Questions B. Point D lines on the diagram such that ABCD is a rhombus. 1. Finds the coordinates of D. So based on the diagram, the point D is the point that is opposite the point B. So here will be the positions of the point D. In a rhombus, the diagonal AC bisect with the diagonal BD. This means the midpoint AC is also the midpoint for BD. So to find the coordinate of the point D, so when 1 times x plus 1 times 8 divided by the total ratio, which is 2, this is equal to the x coordinates of the midpoint, which is the 5. So x plus 8 equal to 5 times 2, which is 10. Then x is equal to 10 minus 8, 2. As for the y coordinates, so when 1 times y plus 1 times 1 and divide by the total ratio, this will give us the y coordinate of the midpoint, which is number 3. So y plus 1 is equal to 3 times 2, which is 6. So y is equal to 6 minus 1, which is equal to 5. Therefore, the coordinates of the point D will be 2, 5. Number 2, show that AC equal to 2BD. So first we're going to find the length of AC. So using this formula, the length of AC will be 9 minus 1 square plus 9 minus negative 3 square. So this is equal to 8 square plus 12 square. The answer is 4 square root 13. And next we're going to find the length of BD. So using the same formula, the length BD will be 2 minus 8 square plus 5 minus 1 square. So this is equal to square root of negative 6 square plus 4 square. So the answer here is 2 square root 13. So now using the concept of ratios, so the ratio AC to BD, this is equal to 4 square root 13 to 2 square root 13. I can write the ratios in the form of fractions. So when AC over BD, this is equal to 4 over 13 over 2 over 13. So here the square root 13 will be cancelled, and the 4 and the number 2 we can simplify it. Now using the cross multiplications method, AC is equal to 2BD. By that we already showed that AC is equal to 2BD. Questions number 10. In the diagram on the right, two straight lines y equal to x plus 4 and 3y equal to x plus 8 intersect at point P. The straight line that passes through point P with gradient 2 meets the x-axis and y-axis at point A and B respectively. Show that A, the coordinates of P are negative 2, 2. As point P is the intersection point of these two straight lines, to find the coordinate P, we're going to solve this using the simultaneous linear equations method. So here I'm going to let the y equal to x plus 4 as equations number 1 and 3y equal to x plus 8 as the equations number 2. So here I'm going to substitute equations 1 into the equations number 2. So it will be 3 bracket x plus 4. This is equal to x plus 8. So expand this, 3x plus 12 is equal to x plus 8. So collect the x on one side and the number on the other side. So 3x minus x is equal to 8 minus 12. So 2x is equal to negative 4. Therefore, x is equal to negative 4 divided by 2, which is equal to negative 2. So next, I'm going to substitute the x equal to negative 2 into the equations number 1. So y is equal to negative 2 plus 4. Then y is equal to positive 2. So here the coordinate of the intersection point between these two straight lines is negative 2, 2, which is the same as the coordinate P. Therefore, we already showed that the coordinate of P are negative 2, 2. Questions B. Show that the equations of straight lines that passes through point P and is perpendicular to straight lines AB is 2y plus x equal to 2. So here we already know that the gradient of AB is equal to 2. So when the gradient of AB, we multiply it with the gradients of the perpendicular line. Let's say we label this as MP. The answer is equal to negative 1. So 2 times the gradient of the perpendicular line is equal to negative 1. Then the gradient of the perpendicular line will be negative 1 over 2. So now we already got the gradient of the perpendicular lines and the coordinates of one point, which is the P that pass through the straight lines. Then we can form the equations. So y minus 2, this is equal to negative 1 over 2. X minus negative 2. So here it will be y minus 2 equal to negative 1 over 2. X plus 2. So expand this, y is equal to negative 1 over 2x. So when negative 1 over 2 times positive 2, we are going to get negative 1. Then move the negative 2 to the right hand side, it will be plus 2. So y is equal to negative 1 over 2x plus 1. So this will be the equations in the gradient form. But here we want to show that the equation is 2y plus x equal to 2. To show that, I'm going to multiply each terms here with number 2. So when negative 1 over 2 times 2, this one here will be cancelled. So 2y is equal to negative x plus 2. Then move the negative x to the left hand side. So 2y plus x is equal to 2. Then we already showed that the equations of these straight lines. Question C. Show that the coordinates of A are negative 3, 0 and the coordinate of B are 0, 6. So here the point A is the x-intercept and the point B is the y-intercept. So here we know that the gradient AB is equal to 2 and the straight line AB passed through the point P with the coordinate negative 2, 2. So we're going to use these informations to find the equations of AB. So y minus 2, this is equal to 2 times x minus negative 2. So y is equal to 2x and minus here will become a plus. So we are going to have positive 4. Then move the negative 2 to the right hand side, it will be plus 2. So y is equal to 2x plus 6. So this will be the equations AB in gradient form. So we know that at x-intercept, the coordinate y is always equal to 0. So here I'm going to substitute y equal to 0 in the equations AB. So 0 is equal to 2x plus 6. Then move the positive 6 to the left hand side. So 2x is equal to negative 6. Then x is equal to negative 6 divided by 2, which is equal to negative 3. Therefore, the coordinate of the point A is negative 3, 0. At y-intercept, we know that the coordinate x is equal to 0. So this is the one that we're going to substitute into the equations AB. So y is equal to 2 times 0 plus 6. Therefore, y is equal to 6. Then the coordinate B will be 0, 6. By that, we already showed that the coordinate A and coordinate B are equal to negative 3, 0 and 0, 6. Questions D. Show that the ratio of AP to PB is 1 to 2. So here you can show this using the length of AP and PB, or you can use the formula of the divisor of the line segments. So here I'm just going to use the length of AP and PB. So the length AP will be the square root of negative 2 minus negative 3, then square it, plus 2 minus 0, then square it. So when negative 2 plus 3, we will get positive 1. So we're going to get square root of 1 square plus 2 square. So the answer of this is square root of 5. And using the same methods, the length PB will be 0 minus negative 2, then square it, plus 6 minus 2 square. So here we're going to get 0 plus 2, which is positive 2 square, plus 4 square. The answer here will be 2 square root 5. So when we take the length of AP divide with the length of PB, so this will be square root 5 divided by 2 square root 5. So here the square root 5 here will be cancelled. So what left here is going to be the number 1. Therefore, AP to PB is equal to 1 over 2. Then we already showed the ratios. Questions 11. In the diagram on the right, BC is a tangent to the circle with center A, negative 4, negative 2 at point B, 1, 8. Find the equations of tangent BC. So the angle formed between the tangent of the circle to the radius AB, it will be 90 degrees here. This means the radius AB is perpendicular to the tangent of the circle. So first we're going to find the gradient of AB. So gradient AB is equal to 8 minus negative 2 over 1 minus negative 4. So this is equal to 8 plus 2, 10 over 1 plus 4, 5. Simplify this, the gradient AB is equal to 2. So when the gradient AB multiply with the gradient BC, as they are perpendicular, the answer is equal to negative 1. So 2 times the gradient BC, this is equal to negative 1. Then the gradient BC is equal to negative 1 over 2. So now we already get the gradient of the tangent BC, and we know that the point B is one of the points that pass through the straight line BC. So now we already have enough information to find the equations of the tangent BC. So y minus 8, this is equal to negative 1 over 2, x minus 1. So y is equal to negative 1 over 2x plus 1 over 2. Then move the negative 8 to the right hand side, it will be plus 8. So y is equal to negative 1 over 2x plus 17 over 2. So this will be the equations of tangent BC in gradient form.